All right, so let's do one last question in lesson 6. I hope maybe you took my challenge from the end of the last video and tried to figure out a better way to do this question that I don't want to say I messed it up because I got the right answer, but I did a really bad job of explaining. So, yeah, let's try this one, which is considerably easier. And because it's considerably easier, I want you to try it before I do it. So hopefully you can read this. If you can, I'll read it out loud. It says, a plant in Michaela's garden was 40 inches tall one day and was 4 feet tall 1 week later. So you're probably going to have to convert that to inches. By what percent did the plant's height increase over 1 week? All right, so I want you to pause the video, try this question on a separate piece of paper, scratch paper, whatever you got, and then play the video and see my way of doing it. Well, actually, I guess you're not even supposed to use scratch paper. We're still supposed to be doing this mental math. So, well, if having the scratch paper helps you keep your mental notes, I suppose you can do that. Or if you like me, you have to give up, use a calculator, you can. All right, give it a shot. All right, so you should be coming back from a pause now. And I'm going to talk you through my mental process of doing this one. So I'm thinking about the fact that we're going from a 40-inch plant to a 4-foot plant. And just in my head, automatically, I'm doing, okay, there's 12 inches in a foot. So 4 times 12 equals 48. So we're increasing from 40 to 48. Okay. And then I say, well, that's an increase of 8 inches. So as long as I can figure out what percent 8 is out of 40, that's the amount of increase, right? I'm not supposed to figure out how much 48 is compared to 40. Like, you shouldn't have an answer of 100 and some odd percent. We just want to know the increase as a percent, and that's the 8 inches. So the question essentially is 8 is what percent of 40? And okay, well, lots of times these are easiest if you can figure out a fraction to work with. I'm already putting 8 over 40 in my head as a fraction. I'm visualizing this fraction, and I'm going, okay, this one I can simplify in my head. So if I divide the top and the bottom by 2, I get 4 over 20. All right, so let me just write that here. And then if I do it again, I get 2 over 10. Okay. And if I do it one more time, I get 1 out of 5. So 8 is 1/5 of 40 is what that means. All right, and then as a percent, this one you should just have memorized, but I'm thinking, okay, 1/5 of 100 is 20. So as a percent, 1/5 is 20%. That means the 1/5 equals 20%. So the plant grew 20%. I wish more of the questions in this lesson were like this. Jeez, why did they give us this one? I'm literally mad about this question. All right. Made me look silly. Let's move on. I think we need to be done with this mental math stuff. Let's move on to lesson 7. Because I want to talk about a couple words in lesson 7 that kind of play a role, at least a little bit, in a Desmos activity I'm going to ask you to do tomorrow. And I mean, it's not a big deal. You probably already know these words, but just to make sure. So lesson 7 is all about percent increase and percent decrease, but they like to use these words markup, which means percent increase. So a markup is usually a store or a word used in stores or when you're selling something. When you increase the price of something, especially by a percent, people will call that a markup. Someone might mark something up just because they want to make more profit, or they might mark the price of something up because the things they used to make it became more expensive. oh, I'm going to mark up the price of these calculators because the copper inside costs more now. So it costs me more to make, so I got to mark up my price. And then there's also the exact opposite, something called a mark down, which is a percent decrease. These you're super familiar with. Markdowns could be like a sale or something's going on clearance because nobody's buying it, so the store's just like, just get rid of it. It doesn't sell. So yeah, as long as you know those two words, you should be okay as we go through lesson 7, and you should be okay in the Desmos activity you'll do tomorrow as well. So Games Galore Superstore buys the latest video games at a wholesale price of $30. Wholesale means how much the store buys it from the people who make it or the people that distribute it, and then they sell it to you for a markup price. So the markup rate at Games Galore Superstore is 40%. Okay, so that means they buy the video games for 30%, then they add an additional 40%, or they increase the price by 40%, and that's what they sell it to you for. That's how they make their profit. So you use your allowance to purchase the game at the store. How much will you pay, not including tax? Okay, good. So they're just trying to make the math easier on us. We don't have to worry about tax. Okay, so write an equation to find the price of the game at Games Galore Superstore and explain your equation. Good. So they don't want us to do mental math anymore. We can go back to equations. You're supposed to have scratch paper and something to write with every time you watch one of these videos with me. I want you to try to do each one of these steps before I do it. Okay, so you write an equation for to find the price of this game. All right, pause the video if you have to, but get it done before I write it. All right, so my equation would be, well, let's see here. Let's have P be the price of the game. Remember, if you're putting a variable in your equation, you always have to define that variable. The price of game. And then the price of the game, P, is just going to equal $30 and then times 1.4. Because 1.4 is the same as 140%. So when I multiply 30 by 140%, I get the original 100% of 30 and an additional 40%. Another one you could have done is P equals 30, the original wholesale price, plus 0.4 times 30, right? Because 0.4 times 30 would get you 40% of 30, and then you add that to the original 30. There's probably other ways you could do it besides this too. Those are just the two that come to mind for me. All right, so solve the equation from part A. So let's see here. I'm going to use this one. So P equals 30 plus 0.4 times 30. Well, that's 30 plus, I know that 4 times 3 is 12, so this should come out to, 12, because the decimal point moves back one, right? So the extra markup on the games is $12, so it's going to equal 42. P equals 42. Okay, so what was the total markup of the game? Okay, so remember that the markup just means the percent increase. So if I'm asking you what was the markup, no, actually, I don't think that's what they mean by this question. So I'm going to take the percent sign off of here, and I'm just going to say that the markup equals just the increase. Because they want to know, like, how much did they increase the price by, right? Like, how much did they raise it from the 30 to what they sold it to you, which was 42? And so the markup was $12. Oh, yeah, now I remember. Now I know what mistake I made. The markup is the increase. The markup, so I'm going to write this up here. Mark markup rate, that's percent increase. And markdown rate is percent decrease. So if they ask you, like, what was the markup or what was the markdown, then you say the actual number, like 12. But if they ask you about a markup rate or markdown rate, then they're asking for like the percent of the markup or markdown. Yeah, so they say it here in the next question. A little rusty. It's been a while since I did this one. All right, so you and a friend are discussing the markup rate. So in this case, that's the 40% that they always raise the price by. He says that an easier way to find the total markup is by multiplying the wholesale price of $30 by 40%. Do you agree with him? Why or why not? So he's saying that you could get the markup, which is $12, by doing 30 times 40%, which is 0.4. I hope that you're able to look at that and know yes or no whether or not it works. The answer is yes, because it's literally what I did in the previous thing. So yeah, I would say it does work. All right, I think that's a good place to stop off. The rest of the lesson is about like discounts and taxes and markup and markdown. But that's essentially what the Desmos activity that I'm going to assign for you tomorrow to do anyway. So I'll leave you to work on that tomorrow. All right.